Okay, so we're just going to be going over expected value and like geometric probability, like using geometry and probability. So to recap, you're one of the 5 scientists that has been chosen for a mission in a submarine by the government. While all the other scientists love orcas, you hate them. Um, so um, so this was the last line of the previous class. You begin to have a bad feeling in the pit of your stomach, but it's too late. You've already signed a contract with the government. So what exactly is our mission? You asked the scientists who entered before you. In your excitement, you didn't actually read your contract. To find the kraken, of course, the map is right here. So the other scientist tells you, we all know the kraken is, or kraken, okay, is not in the green circle, but it has to be in the blue circle. The radius of the green circle is 1 mile, while the radius of the blue circle is 2 miles. You know math. If we were randomly placed inside the blue or green circle, what is the probability that we are in the green circle? Okay. So you all can solve this. I think some of you might have not a background, but like might know how to do this. So like if you do, then you can answer the question. Okay. So I see 2 answers. One of them is pi over 4 and the other is 1 over 4. The white and black lines don't matter. That's just like something random, like a background for the thing. Yeah. Yeah, it's irrelevant, but yeah. Okay. Yeah. So the probability would be 1/4 is what you answer. And the person asks you, how do you know that's the answer? So when you have a problem like this, you would divide the area of the green circle by the blue circle, like the total of the blue circle, which would be 1/4. And the reason we're doing this is because we're trying to find what is the probability that we select something in the green circle out of the total thing, right? Because the question is asking, what is the probability that we are in the green circle? So the green circle divided by the total circle. So that's 1 pi over 4 pi using pi r squared, and we get 1/4 as our answer. Um, so yeah, it simplifies down to 1/4. So you go to one of the other scientists to get to know them when the submarine starts shaking. What's going on? You exclaim. A group of orcas attacked us. So you start screaming. One of the others tries contacting headquarters about this issue, but your transmission is choppy. You stop screaming and start thinking and find the digital manual for what to do and all the dangerous situations you could possibly be put into. You find the Orca section, but it's encrypted by math prompts. Hey everyone, we need to solve this problem, you shout, drowning out the chaos that ensued from the Orca attack. Everyone focuses on the task at hand. What is the expected value of, you start reading, but you're cut off. So what exactly is expected value? So expected value is just the weighted average of each of the expected outcomes in a problem. So when you're rolling a 6-sided dice, for example, a fair 6-sided dice, for example, there are 6 possibilities. So you take each of the possibilities and the value you expect for each singular possibility and multiply it by the probability of that. And then you add that all together. So when you're rolling a fair 6-sided dice or die, there are those 6 possibilities, each with a 1/6 probability. So you do 1/6, which is the probability of rolling 1, multiplied by 1, plus 1/6, which is the probability of rolling a 2, plus times 2, and then so on and so forth. So you get 1/6 times 1 plus 1/6 times 2 plus 1/6 times 3 plus 1/6 times 4 plus 1/6 times 5 plus 1/6 times 6, which is 3.5. So that would mean that the expected value of a singular roll of a fair 6-sided die would be 3.5. So you continue reading the original problem. Find the expected value of the spinner shown in the diagram. Add the sum of the digits in the decimal representation and click that answer. Okay, yeah, this diagram. So what is the expected value of one spin of the spinner? And yeah, find the sum of the digits in the decimal representation of that. So I'll give you all like 2 minutes. You are allowed to use a calculator, but you should be able to do this in your head. Or not in your head, but like with the paper. Obviously, you will be unable to click the correct answer. So just like put your answer in the chat. Yeah. Okay, so I have seen 3 answers so far. If you do have any questions, feel free to like say like you don't understand or something in the chat. Like I can re-explain expected value or like anything you need to re-explain. Yeah, the figure and the angles are to scale. Are to scale. Yeah. Yeah, if it was not to scale like the angles, then you would be able to solve. Okay, so okay. After I explain this problem, I will re-explain expected value. So basically, you would get, okay, so let me just quickly explain expected value. So expected value is where you multiply the probability, okay, let me type this, probability of an event multiplied by the value you would get from that event, and then you just add them all together. So you probably don't know the notation for summation, but it would just be the sum of these. So in this scenario, for example, this 13 would have a 1/8 probability because we could fill the circle up with 8 of these, right? This is 1/8, right? So we would multiply that 1/8 by 13 and we would get 13/8 plus, and then the probability of getting a 2 would be 3/8. So 3/8 times 2 is equal to 6/8. And then the 6 would have a 1/4 probability. So that would be 6 times 1/4 or 6 times 2/8 is 12/8. And then this 9 would also have a 1/4 or 2/8 probability. And we would multiply that and we would get 18/8, right? So we'd be able to add these all together, right? And we would get 30, 40, 49/8, right? As the expected value. However, in the question, it says that you want the decimal representation of this. So you would convert this into a decimal. 49 divided by 8 is 6.125. So now all you have to do is find the sum of the digits in this. So 6 plus 1 plus 2 plus 5 is 14, right? So that means that the answer, that the sum of the digits of the expected value from this event would be 14, or this. What do you mean? This is a shortcut. Like, I actually don't get like what question you're asking. Okay, so for expected value, you don't add all the values up. You I don't think you did it correctly. You weren't supposed to just add the values up. You're supposed to take each of the values that you expect. So this, right, is event 1, right? So you would take the event and you would multiply it by the probability. So you'd take the actual value of the event. So this event has 13 and has a value of 13, and you would multiply it by the probability, right? So the probability would be 1/8, so 13/8. And then this has a value of 2, so you'd multiply it by the probability of getting that 2, which is 3/4, or which is 3/8. Oh, well, you made, I don't know, you made so many mistakes, you got it right. But yeah, yeah, so you would multiply each of the values of the events by the probability of the event. Okay. So it is correct. So you expect to be met with the answer to your problems, but you are met with another problem. So how much money in dollars would you expect to gain after 100 coin tosses if on a fair coin, a head flip would gain you 50 cents, while a tail flip would lose you 70 cents? So this is just another example of expected value this is just another expected value from you explain putting your shipmates at ease. So yeah, solve this problem is basic. Yeah. Also, I don't think I worded it properly because it sounds weird now that I'm reading out the question, but you understand what it's asking. So some of you are yeah, okay. Some of you, okay, I don't know what explanation you're putting in the chat, but yeah, some of you are, or a lot of you are getting the same answer. So yeah, this is, again, this is just another expected value problem. So what you would want to do is you would start with each event, right? One coin toss. What is the expected value of that? So one, and then this is supposed to be a coin, right? Just pretend like it is. Right, so you would expect, so the head flip would have a 1/2 probability, right? So that would be uh sorry, um 50 cents. And the tail flip would lose you 70 cents, right? So um yeah, okay. So for yeah, so 1/2 times 50 minus 70 is equal to -10. And then you would multiply it by 100. And okay, yeah. So that would be negative 1,000 cents, which is negative $10. Um, so yeah, for each, you would expect to lose 10 cents. Okay, yeah, I messed up my answers. I'm sorry. This should be, yeah, it should be a -10. But yeah, it would be negative $10, not because, right, for each individual coin toss, you would expect to lose 10 cents because 50, 50, you would have a 1/2 probability of each, right? So you would expect 50 times 1/2 minus 70 times 1/2. And that's 25 minus 35. Yeah, 25 minus 35 is -10 cents. And then after 100 coin tosses, that would be negative 1,000 cents, which is -$10. And I did mess up my answers, but it should be -10, not -20. So pretend like it was -10 earlier. Okay, so you got that correct. Okay, now you can take it.
On your screen, you read aloud, last question, what is the expected value on a multiple choice test with 15 questions if each question has a 1 out of 4 probability of being correct, and each correct answer is worth 20 points, and each incorrect answer is worth -4 points? Assume you are randomly guessing for each question.
Oh, I got it. It's 30. So now it'll be them. Oh wait, you did say 30.
Okay, so the answer is 30 because so first you would multiply the probability of getting something correct by the points that you get when it's correct, which would be 1/4 times 20. And then you would add the probability of getting something wrong times the amount of points you lose when you get it wrong, which would be 3/4 times -4, which would be 8/4, which equals 2. And since there's 15 questions, you multiply 2 by 15, you get 30.
Yeah, there was some confusion about that question. So do any of you have any questions? Because many of you did not get it correct.
Your computer chirped, an Orca tranquilizer has been emitted by the submarine. No more attacks. Back to the mission. 4 days later, you found the Kraken. It lived in the deepest part of the Marina Trench. Unfortunately, it tried to eat your submarine, so now your radio and lights are damaged. You need to find the safe in the submarine with the tools, with the radio, with the backup radio. You know there is a button on the panel in front of you. You need to click the salmon button for your flashlight. If the gray area will initiate self-destruct mode, what is the probability your ship self-destructs, assuming you only get one chance to click anything in the panel? Express your answer as a decimal rounded to the nearest hundred.
I have a question.
Yeah.
So the gray stuff, would that be so the red button? I'm confused. What would the gray stuff be? Because like dark gray or the light gray?
This area.
Oh, okay.
Yeah, it's like that. Yeah. Just ignore the borders. And for this question, you all can use a calculator.
The question says to express your answer as a decimal, rounded to the nearest hundred. Okay, so some people are getting it. What you would do is you would take the area of the entire rectangle part, which is 10 times 14, which is 140, and subtract the area of the button, which is 9 pi, and put it over the area of the whole thing, which is 140. And when you put this in a calculator, it's going to be approximately a 0.8.
Yeah, some of you mistook that 6 inches for meaning the radius. That is not the case. Otherwise, it would be like a much lower value for the probability. And also, I just think some of you didn't do the math correctly. Like you did the area of the button divided by the area of the total rather than the area of the gray area. So like make sure you're checking your
A flashlight dispenses. Now all you have to do is find the safe with the extra radio. Does anyone know where the safe could be? Only one other person is awake, and she tells you it is behind the dartboard in the dining room, bedroom, living room space. You walk up to the dartboard and see the following instruction. So you want to open the safe, you need to be able to hit the gray region of the dartboard with at least one of the 3 darts. The catch, you need to stand 10 feet away from the dartboard, otherwise the safe self-destructs. The problem is you don't have any sense of aim. If the length of each of the light blue line segments is 2 inches, what is the probability you hit the gray region with the darts at one of your 3 darts onto the nearest 1,000?
Also, remember probability is always going to be between 0 and 1. So if you get an answer like 2, that's automatically incorrect. If you say 2%, that could potentially be correct, but that's like not answering in the format the question's asking for, which is like round to the nearest thousand. So you're assuming that it means decimal and not percentage form. Okay, so you all are getting a variety of different answers. So basically this uses a lot of concepts that we have learned, and you might not have applied all of them. And still 1.5 is greater than 1, so that is not a valid probability. So basically, so you know that the length of each of the blue segments is 2 inches, right? So now what you have to do is find the area of the gray region, right? So the gray region, or whatever's in the gray region, like blue and yellow circles, would have an area of 9 pi, right? Because the radius of the blue and yellow circle combined would be 3 inches. And then the radius of the gray circle would be 5 inches. So we would have 25 pi minus 9 pi as the area of the gray region. So this is equal to 16 pi as the area of the gray region. And now we know that we want to find the probability of hitting the gray region, right? So 16 pi out of the total of 49 pi, because that would be the area of everything inside the outermost circle, would be the probability of hitting a gray, of hitting the gray region with each of the darts, right? You would have a 16/49 probability each time. So now what you want to do is you want to find the probability you hit it with at least one of the 3 darts. So we will use complementary probability or complementary counting, or no, complementary probability in this scenario, right? So we want to find the probability you hit it with 0 of those darts. So you do 33/49 to the power of 3, because remember 1 minus 16/49 is 33/49, right? And we're raising it to the power of 3 because we have 3 darts. So that's a probability that each time you miss the gray region. So 33/49 to the power of 3 is equal, okay, 33/49 to the power of 3 is equal to, okay, sorry, is equal to 0.305 percent. So we subtract that from 1 because that's the probability that we do not hit the gray region with any of the 3 darts. So the complement of that is the probability that we hit the dartboard with at least one of those 3 darts. So the probability would be 0.695.
I have a question.
Yeah,
So it says each gray line is 2, right?
yeah, 2 inches.
So how would, like, the blue and yellow, you said the blue and yellow would be 9 pi,
Yes,
and
because, yeah, okay. So this shows that the diameter of the yellow circle would be 2 inches. Yeah, yeah.
bruh,
So,
okay, thank you.
yeah, no problem. But yeah. Um, okay, does anyone have any other questions? Because I don't know if anyone got that right. Okay, one person got it right, so yay. Okay, yeah, and also you should probably drink water, that will help. Yeah. Okay, so basically what happens is you find the radio and contact headquarters, and within the next hour you're rescued and are suddenly rich because of your contract. So what would you do with the millions of dollars the government gave you? And we have a code. So yeah. But what would you do with the millions of dollars that you get? I think Elon Musk is richer than you, or would be richer than you, even if you got millions of dollars. Like he's a billionaire. All of you are just fixated on Elon Musk. Yeah, college money is very good of an investment. Okay, out of curiosity, would you all rather do a geometric probability first or expected value for the Kahoot? Well, we'll probably only get to one of them. Okay. So I have two people who each want a different one. So could everyone in the chat say like geometric probability or expected value? I am currently, oh, would you all rather do geometric probability or expected value for the Kahoot? Okay, I am seeing more geometric probabilities. So we will do that. Yeah, okay. So it is loading. Sorry for it being slow. Yeah. Okay, this seems like it's gonna take forever. Okay. And because my computer is slow, well, as usual, I will enable the questions showing. Okay. Okay, so make sure to join. Okay, everybody joined. There are more than 3 of you. There should be like 10 of you. There are 4. You can, okay. If you're having trouble joining, try getting another device. Okay, but like, actually though, like join. Okay. So we're doing geometric probability, as you can tell. Yes. Well, okay, I did not realize that would kind of this wrong. But yeah, the correct answer was 1/2 or 4/8. Yeah, next time to simplify. Yeah. Find the probability of the shaded region. Okay, yeah, so it is yellow. So remember, firstly, probability will always be less than 1. So like technically that was the only correct answer that could have been possible. So you could have used that. Find the probability of the shaded region. Some of you might actually be doing the math, although like you could notice like similarity between the shaded or the larger rectangle and the smaller one, and use that. So it would be I think it would be 4/5 because the center yeah, okay, the center one had a height of 3 and a length of 9, and the larger one had a height of 9 and a length of 15. So 3/15 is 1/5. Also, maybe it was not a good idea to do some autoflip. So what's the probability of a free turn? So it's 1/4 because that has 90 degrees out of 360, which is just 3/4. Yeah. Okay, what is the probability that you lose a turn? And probably should simplify. Yeah, it's 7/18 because 140 degrees out of 360 degrees simplifies down to 7/18. Okay, what is the probability you receive 10 bonus points? Which is that 30-degree sector there. Okay, yeah, 30 degrees divided by 360 is 1/12. Yeah. Okay, what is the probability you move forward 2 spaces? So it's that 70-degree sector there. Okay, yeah, it's 7 out of 36 because 70 over 360 simplifies to that. So what's the probability you lose 5 points? So that's a 30-degree sector here. Okay, so yeah, it's 1/12 because 30 over 360 is 1/12. Okay, what's the probability of hitting the bullseye of the bullseye? Its radius is 1/2 of a centimeter, and the entire dartboard has a radius of 11 centimeters. Okay, yeah, so it was 1 over 484 because 1 over 2 over 11 is 1 over 22, and you square that and you get 1 over 44. So good job, Advika. Good job to all for getting first starts, and good job to all of you all, Aryan and Sana. Good job. Yeah. So, okay, so we only have 3 minutes left of class. So I don't think we would have time to get to this. But I don't think that the backwards name is very hard to decipher. Also, I do not know what it's doing. So I'm gonna close it. Okay, but good job, everybody. Thank you for coming to class. And I don't think I have posted the slides for the past few classes. I will make sure to do that and post the recordings. And yeah, sorry about that. So